Hello, chemistry students. Welcome back. I'm Mr. Silverstein, and I'm your conceptual chemistry teacher. Today, we're going to talk about different branches of chemistry and give you an overview of some of the things that we're going to be working on. I'm going to share my screen, and we'll get started. So this is Unit 1, Concept 1, and it's an introduction to chemistry. And so this lesson is going to explore the introduction to chemistry, the different types of chemistry. We're going to do a review of mass, and we'll also talk about the purpose of learning and studying chemistry. These slides are posted in your Google Classroom. I want you to take personal notes in your spiral notebook, and then complete the activity for today's assignment. So our objective is to explore the different aspects of chemistry in various fields that have real-world applications. A lot of what we're doing in this conceptual chemistry course is so that you can apply these particular pieces of information and knowledge into the real world. So what is chemistry? Well, chemistry is the study of the composition of matter and the changes that matter undergoes. And matter is anything that has mass and occupies space or takes up volume. So you have mass and you occupy space, so you matter. But matter also can be in various states, and we're going to explore that in our next unit. But matter can be solid, liquid, or a gas. So volume versus mass. And this is an interesting concept that some people sometimes have a little bit of difficulty with. There's the old joke. What weighs more, a pound of feathers or a pound of gold? Well, in your mind, you might think the pound of feathers, but they both weigh the same. They're both a pound. So let's take a look at these objects on this balance beam. Here we have two sets of objects that have equal mass, but the yellow balls will take up more volume than the blue balls will. That's because the yellow balls have a lighter mass. And so we have to be very careful when we start to examine different elements that are out within our exploration of chemistry. Some are heavier than others, and some are more dense than others. And we'll explore more of that as we move forward. Because living and non-living things are made up of matter, chemistry affects all aspects of life and most natural events. On the living things, many that you're familiar with, we have people, we have flowers, butterflies, dogs and animals, trees, and little plants that grow in the earth that make us food. On non-living things, we have things that are, books and metals and liquids and chemicals and clothing and different kinds of implements, tools. So there's a variety of things that are both living and non-living, and they're all made up of matter. We talked a little bit earlier about mass and volume, mass and weight. Let's take a look at this. I'm going to want you, when we're done with this discussion, to pause the video and complete this bubble map in your notebook. So, let's take a look at weight. Weight depends on how much gravity is acting on something at that particular moment. It is how strong the gravity pulls on the matter. And you would weigh less if you were in space than if you were on Earth. Mass stays the same no matter where you are. It's a measure of how much matter an object has. And it's also a measure of how much inertia an object has. Inertia has to do with how an object can move. Now, the common part between weight and mass is the more mass an object has, the more weight it has. So make sure you get this into your notes and jot down some questions that you might have for this that we can talk about in our next session. Remember, these slides are also on your Google Classroom, so you can open that up and take this down. Let's talk about Newton. Now, the Newton, its symbol is N, is an international system of units, derived unit of force. And so we use the Newton to determine how much force something has. It's named after Sir Isaac Newton in recognition of his work on classical mechanics, specifically Newton's second law of motion. And it's defined as that force necessary to provide a mass of 1 kilogram with an acceleration of 1 meter per second squared, or super fast. So the Newton is how much force is needed to take 1 kilogram of an object and accelerate it, moving at 1 meter per second squared. That's how fast it can move. And so a Newton is going to be an important part of what we're going to be working on. As we started looking at mass, your mass may always be 56 kilograms. Your weight on the Earth is about 560 newtons because all of that gravity is pulling you down. Your weight on the moon, however, is around 90 newtons because there's no gravity pulling you. But it makes no difference where you are, your mass is always 56 kilograms. So remember, chemistry is the study of matter, its properties, and how and why substances combine or separate to form other substances, and how substances interact with energy. And chemistry is part of everything in our lives, and every material in existence is made up of matter, even our own bodies. So I want you to take a break for a moment, take about 2 minutes. I want you to look over your notes, and then we'll move on to the different branches of chemistry. Welcome back, chemistry students. Let's move on to branches of chemistry. This is a fairly large chart, so you can take some time to jot it down. We're going to look at the branch of chemistry, an explanation of what it does, and a real-life example in how you can put it into action or put it into some kind of career. So, analytical chemistry focuses on the composition of matter. What is in that matter? What's it made up of? And a real-life example of that would be forensics. We use forensic analysis to determine what made up something, and we can determine whether a crime was committed or whether something is not functioning properly. The term forensics is used for a very detailed examination of something. There's also organic chemistry, and that's the study of the chemicals that contain carbon. So anything that contains carbon is organic chemistry. Now, a real-life example is organic chemistry studies the manufacturing of diamonds and coal as a fuel source, and manufacturing that material called nylon. And so depending upon what you're working on, it may be an aspect of organic chemistry. Now, biochemistry is the study of the processes that take place in organisms. And you all studied biology, and so there's a lot of processes that go on in organisms. And a real life example is something as simple for you, but complex chemistry-wise, digesting food. Can also use biochemistry for developing and curing diseases. A lot of what's going on right now in developing a vaccine for the coronavirus is working with biochemists who are doing experiments and testing different chemical compounds to see if they can neutralize the coronavirus. We then have physical chemistry. Physical chemistry is the study of the mechanisms, rate, and the energy transfer that occurs when matter undergoes change. And so if you were in our classroom right now, you would look up at the ceiling and see fluorescent lights. Fluorescent lights is taking energy from electricity and transferring it through gases in a tube to create that light. Just like neon lights outside businesses. That's using a small amount of neon gas and an electrical charge. And then we have inorganic chemistry, and that's the study of chemicals that do not contain any carbon. Inorganic chemistry, a real life example of that, studying water. That water molecule only has hydrogen and oxygen in it. But water is one of those great universal solvents. And it's amazing how water can be used for so many things. So those are the 5 branches of chemistry that we're going to be focusing on this semester. Now, there is a supplemental video that's attached to this assignment. When you're done with this video portion, I want you to open up that video, take some notes. It's only going to run about 5 minutes or so on the different branches of chemistry. And so let's do a review. There are 5 principal branches of chemistry we're going to study in this course: analytical chemistry, organic chemistry, biochemistry, physical chemistry, and inorganic chemistry. Chemistry is based upon all matter. Living and non-living things are matter, and matter has mass and occupies space. So that's our introduction to chemistry today. And you have an assignment for today. I want you to open up the tab for Monday, and there's a form in there, and respond to the questions. When you're done with the questions, there's going to be a writing component. And you're going to answer this question in a complete and comprehensive paragraph. You're given an opportunity for a career in chemistry. Choose one area of chemistry you would like to work in for the rest of your life. Which one would it be and why? And this will be your first writing assignment for this semester. Well, that's all I have for you now. You guys have been great today, and we'll see you next time.